For centuries, humanity viewed the heavens as a grand, predictable clockwork. We believed that with enough mathematical precision, the future of our planets and our weather could be foretold with absolute certainty. However, a terrifying realization has emerged from the depths of physics and mathematics: our universe is not a stable machine, but a realm governed by chaos. This scientific nightmare, which mirrors the existential dread found in the world of three-body, suggests that even the slightest tremor in gravity or a microscopic error in calculation can lead to total collapse. The first crack in the facade of a perfect universe appeared in 1889. During a mathematics competition hosted by the King of Sweden, the brilliant Henri Poincaré attempted to prove the eternal stability of the solar system. He sought to guarantee that Earth would never drift away into the void. What he discovered instead was the abyss. Poincaré found that when three celestial bodies interact, their orbits become impossible to calculate with long-term certainty. A discrepancy as thin as a human hair in their initial positions could lead to a difference of tens of thousands of miles over 10,000 years. This revelation, often called the Chernobyl of mathematics, proved that the three-body problem is inherently unsolvable and unpredictable. This sensitivity to initial conditions was later echoed in the mid-20th century by meteorologist Edward Lorenz. While attempting to simulate weather patterns, Lorenz rounded a decimal from 6 places to 3, assuming such a tiny change was inconfiscable. To his horror, that 1 in 1,000 error amplified through the atmosphere until it created an entirely different storm. This birthed the concept of the butterfly effect, the idea that a butterfly flapping its wings in South America could trigger a tornado in Texas weeks later. Lorenz visualized this chaos through a geometric pattern known as the Lorenz attractor, which strangely resembles a pair of butterfly wings or a deep, haunting eye. Despite the apparent madness of chaos, scientists like Mitchell Feigenbaum later discovered a hidden order within the turbulence. He found a universal constant, 4.6692, which appears whenever a system transitions from order to disorder. This suggests that whether it is a dripping faucet or a rushing river, all things follow a mathematical rhythm as they lose control. Furthermore, Benoit Mandelbrot revealed that chaos possesses a visual signature known as fractals, infinite, self-repeating patterns found in everything from the jagged edges of clouds to the intricate networks of blood vessels in the human body. In the narrative of three-body, this mathematical nightmare is a death sentence for a civilization, driving an alien race to flee their unpredictable suns. Yet, in our reality, chaos is not merely a harbinger of destruction. It is the very foundation of life. Total order is stagnant and dead, while total disorder is nonsensical and fleeting. Life thrives only at the edge of chaos, where there is enough stability to pass on information and enough flexibility to evolve. While we may never be able to fully control or predict the future, the fluttering wings of our smallest choices are what allow complexity and freedom to exist in an otherwise silent universe.